Okay, Assalamualaikum and hi. So yang ni introduction untuk chapter 6 which is 6.1. Okay, so chapter 6 is about chemical equilibrium. So dalam chapter 6 kita ada 3 subtopic. Okay, 6.1 dynamic equilibrium. So untuk the first subtopic just introduction tentang equilibrium. Okay, untuk 6.2 equilibrium constant. So sini ada banyak calculation. And 6.3, so ini pun tentang dia cerita dia principle untuk ini untuk explanation lah. So kita akan pergi untuk 6.1 dulu. Okay, so learning outcome for 6.1. So explain what is reverse reaction, dynamic equilibrium. Okay, and kita ada satu teori, okay, law of mass action. Then kita state 4 characteristic of system at equilibrium, and from this equilibrium we have graph. So we need to explain and interpret the graph for concentration, reactant and product versus time. Okay, because kita belajar untuk reversible reaction, so this graph only for reversible reaction. So for equilibrium, okay, actually we have two type of reaction. Okay, which is reversible reaction. Okay, reverse mean forward and reverse. So non-reversible meaning hanya berlaku forward reaction saja. So full-headed arrow. So in reversible reaction, okay, when reactant react to produce product, so after product form, it will reverse to decompose and form back reactant. But for non-reversible reaction, okay, when the reactant react, okay, for example, and A and B, it react and it will produce product only. So only product form at the end of the reaction. Okay, but for reversible reaction, kita akan get back our reactant because after C is produced, okay, it will start to decompose to produce back A and B. Okay, reversible sign kamu tahu. Okay, so kita ada half-headed arrow for forward and reverse, and for non-reversible sign, full-headed arrow. So this is the example of the equation. So this one is a definition for reversible reaction. So reversible reaction is a chemical reaction that can proceed in both forward and reverse direction. Definition for dynamic equilibrium. So dynamic equilibrium refer to the concentration for both reactant and product stop changing because forward and reverse reaction are equal. So concentrationnya dah tak berubah, so constant. So we say that concentration constant and forward and reverse reaction equal. So this condition we call as dynamic equilibrium. Rate of forward equal to the rate of reverse reaction. Okay, then we have a characteristic of a system at equilibrium. So actually we have 4 characteristics. Okay, the first one, the chemical equilibrium can be established only in a closed system. Okay, why in a closed system? Because no matter is out, so we can maintain the equilibrium at the system. Okay, kalau ada yang keluar, nanti dia still akan moving, so dia tak akan dia sentiasa berubah, so still tak boleh maintain equilibrium. So second character, okay, so this one tadi kita dah cover tadi, rate of forward equal to rate of reverse reaction. So macam dalam gambar ni, contoh rate of water flow in, okay, from the tap equal to the rate of water flow out. Okay, ataupun rate formation of NO2 equal dengan rate of reverse reaction, meaning rate of NO2 to O4. The third one, equilibrium can be reached from both direction, meaning kalau dia forward reaction, dia boleh form equilibrium. So reverse reaction pun boleh form equilibrium. Okay, and the last part, macromolecule properties. So macromolecules such as concentration, okay, for both reactant and product, okay, pressure and color are constant. Okay, for example, in this reaction between reaction of hydrogen iodide HI decomposed to produce hydrogen gas and iodine. So iodine in a gas. So dalam botol ni ada iodine, dan warna purple ni ialah iodine gas. Okay, so the purple color, okay, refer to this one. Okay, purple color of the iodine will remain constant. So remain constant mean HI decompose rate-nya sama dengan hydrogen dengan iodine react to produce back HI. Okay, meaning forward and reverse reaction, okay, the rate reaction dia still lagi berlaku, tapi pada rate yang sama. Rate forward equal dengan rate of reverse. This graph is graph of concentration versus time. So kita ada 3 condition. Okay, refer to this equation. So kita ada N2O4 produce 2NO2. Okay, so 2NO2 produce N2O4. Okay, for the first graph kita ada start with higher concentration of NO2. So kalau higher concentration of NO2, low concentration of N2O4, meaning ini ialah NO2 to NO2 produce. Okay, initially we have NO2 and 2O4. Okay, because initially we have higher concentration of reactant. So when time increase, okay, meaning dia akan pergi kepada forward reaction. So N2O4 will produce. So N2O4 increase, okay, until certain time. So certain time we call as T1 time, yang dotted red line ni. So concentration of N2O4 and NO2 remain unchanged. Okay, dia constant, remain unchanged. Okay, so kita ada less NO2, so 0 NO2, higher N2O4. So meaning this reaction ialah from N2O4 produce NO2, less N2O4, meaning the reaction goes forward, more NO2 produce. So graph ini meningkat at after certain time, T1 time, concentration untuk both reactant and product remain constant ataupun unchanged. Okay, so kalau yang ini kita ada dua-dua concentration untuk NO2 dan N2O4 at initial concentration. So meaning yang ini dah berlaku forward and reverse reaction. Okay, tapi pada certain time sama juga equal concentration untuk NO2 and N2O4 remain unchanged. So at this condition we call the system is at equilibrium. So remember, at equilibrium the concentration are not the same. Maksudnya dia tak sama. Okay, kalau kamu tengok yang ini concentration N2O4 higher than NO2. Ini pun sama, N2O4 higher than NO2. Tapi dia constant. Constant meaning tak ada increasing ataupun decreasing of concentration. See these 3 different condition, okay, to explain why at equilibrium does not mean the amount of product and reactant are equal. Okay, we have reaction between A and B to produce C and D. So in this container we have A. So we have the first condition. Let's say that if the product react more easily, meaning product ni lebih senang react. Okay, so C and D react easily, meaning this is the reverse reaction. So C dengan D akan produce more A and B sebab dia react lebih cepat. So reverse reaction. So bila reverse reaction, dia akan produce more A and B. So we say that the equilibrium is shift to the left. C and D react lebih cepat. Bila dia react lebih cepat, dia akan menghasilkan A dan B. Okay, prefer reverse reaction. Initially we have no product, okay, zero product. After certain time, okay, we have products. So until this time, T1 time, concentration of reactant and product constant. Why concentration of reactant higher than product? Okay, tadi kita kata C and D react easily to form B and A. So meaning dia akan shift to the left. So bila shift to the left, meaning at the end of the reaction kita ada more reactant. So bila more reactant, okay, higher concentration of reactant. So ratio product of reactant is less than 1. Okay, because we have more reactant. So more reactant, so reactant increase, so ratio will decrease. The next one we have second condition. So this condition reverse from the first condition. So at this condition, A and B react easily to form C and D. Okay, lebih senang untuk produce C dengan D. Meaning this is prefer for forward reaction. So when forward reaction, kita akan form more C and D. So at this condition, we say that equilibrium shift to the right. So bila shift to the right, dia akan produce more C and D. So kita katakan concentration of product higher. So when concentration product higher, ratio will increase. So ratio product to reactant greater than 1. Okay, the third condition. Okay, so both reactant dengan product, okay, rate of reaction dia sama. Okay, kesenangan dia untuk react dia sama. So C and D produce A and B, at that same time B and A react produce C and D. So di mana equilibrium position tu? So dia berada di tengah-tengah. So at this condition, kita katakan reactant and product concentrationnya sama. Okay, so bila sama, dalam graf dia akan overlap. So ratio product and reactant equal to 1. Okay, so remember at dynamic equilibrium after T1, okay, so reaction tu still lagi berlaku. Okay, the reaction did not stop, tapi rate forward and reverse reaction are equal. So rate equal and concentration constant. So this condition we call as dynamic equilibrium. Rate equal, concentration constant. For 6.2, nanti kita akan belajar calculation untuk menggunakan law of chemical equilibrium. So from definition, okay, law of chemical equilibrium, or known also as law of mass action, defined as, okay, the multiplication of the concentration of product raised to its power equal to this coefficient in the equation divided by multiplication of the reactant each raised to its power. Simplifykan menggunakan formula. So for example, here we have reactant A and B. So coefficient A, coefficient B. So product C and D. So coefficient C, coefficient D. Coefficient tu maksudnya selepas kita balance kan, kita ada yang nombor depan tu reactant, so ini untuk product. Okay, so ini yang dimaksudkan tadi tu law of mass action. So constant sama dengan concentration untuk product kuasa koefisiennya. So ini concentration product C, kuasa C times concentration of D, kuasa D. So kalau product tu ada 3, jadi 3 lah, raised to its power of coefficient, equal over concentration of reactant raised to its power. So kalau A kuasa A, B kuasa B. Okay, nanti kita akan sambung dengan 6.2.